Good morning. Welcome to Sanjay Godawat IIT Medical Academy. Today we'll discuss about Icon A Physics module paper. In this module paper, we have the numerical changes and the teacher choice questions from 9th question to 23 questions. So we will discuss those questions only, right? See. And the question number 9, it is given that a physicist works in a laboratory where the magnetic field is given 2 Tesla and she wears a necklace enclosing area is given, it is in centimeter square. So you have to convert into meter square of resistance 1 ohm. Because of the power failure, the field decays to 1 Tesla. Initially we have 2 Tesla. After the power decay, the magnetic field is reduced to 1 Tesla. So the change in magnetic field, which is written as dB, which is 2 minus 1, which is 1 Tesla. And area of that necklace, it is in meter square we are converting. So 10 power of minus 4, which is minus 2 meter square. And the resistance also mentioned. The electric charge they are asking here. So in the necklace, assuming the magnetic field is perpendicular to the area covered by the necklace. So induced charge expression can be written as minus d phi by resistance. D phi is a flux. So flux written as magnetic field into area upon resistance. Magnetic field, which is nothing but the change in magnetic field or decrease in the magnetic field, which is 1 Tesla. Area, which is 10 power minus 2, and the resistance is nothing but 1 ohm. So the charge, which is equal to 10 power of minus 2 coulomb, which is written as 0.01 coulomb. So our answer it is first option 0.01. Okay. Now coming to the next question, question number 10. In the question number 10 is mentioned that coil of 30 turns, total number of turns is mentioned, and wire, it is 10 centimeter square, is placed perpendicular to the magnetic field also mentioned B, and the coil is suddenly withdrawn from the field. So the coil is removed from the magnetic field, so absence of magnetic field it will come, and the galvanometer is connected to the coil, and it is indicated the charge it is given 100 microcoulomb around the circuit. The combined resistance of the coil and the galvanometer. So this question also similar to the previous question only. So induced charge, which is the change in magnetic flux upon the resistance, change in flux written as magnetic field area and upon resistance. The charge is given 100 micro, 10 power minus 6. Magnetic field, which is 0.1. Area, which is 10 centimeter square converting minus 4. But in this we have the number of turns also, just multiplying with number of turns, which is n. So that number of turns is given 30 and asking the resistance. So simplify for the resistance, which is 0.1, one cancellation, and here also one cancellation, 10 power minus 3 into 3. Here is minus 4 carrying plus 4. Then after simplification, the resistance we will get 30 ohms. So 30 ohms we have the option as second one. Okay. Now coming to the next question, question number 11. So what is given in the question number 11? The magnetic field in a certain region. The magnetic field is given in the vector form, and the magnetic flux, they are going to be asked the magnetic flux. When the loop of area, it is also in centimeter square, converted into meter square. placed in YZ plane. So placed in YZ plane, X, Y and Z. The coil is placed in YZ plane. So the area vector, if you draw, which is nothing but along the x-axis, so the area vector which is 5 centimeters square, if you write in vector form, it is along x-axis, so that you can write I cap. So magnetic flux we know is a scalar product B bar dot of A bar. So magnetic field is given 40I 15 K cap is multiplying 10 power of minus 4 dot of area which is 10 power of minus 4 I cap. So we know how to calculate the dot product. So simply you have to take the I to I, which is flux phi equal to 40 into 5, which is 200, 10 power of minus 8. So this value written as, in terms of nano is mentioned, nano, so that 2000 into 10 power of minus 9 Weber, minus 9 written as nano, so 2000 nano Weber. It is over the magnetic flux required, which is passing through the given loop. So 2000 is nothing but is option C. Okay. Now coming to the next one, question number 12. What is given in the question number 12? The square loop of side is changed into circle. Square loop, the shape of the coil is changed now. Square to circle in the time of 0.2 seconds with plain magnetic field, normal to magnetic field is given and EMF they are asking. According to the Faraday's law, induced EMF, which is written as minus d by dt of phi, which is magnetic field into area. If number of turns is given, you have to consider it. In this question, no number of turns, so I taken only one turn in the loop. So magnetic field is kept constant, but the square loop to circle is changed, nothing but area is going to be changed. So first I am calculating what is the area. Square loop, each 0.22 meter, converting into the circle. What is the radius of the circle? Don't know, we need to find. So the perimeter or the total circumference 4 into 0.22 for the square, or perimeter which is 2 pi r, pi 22 by 7 r. So cancellation 0.1. So simplify, which is 2 times. So 0.14 meter is the radius of the given loop. Now what is the area? Side square 0.22 square, which is 0.40484 meter square, and area of the given circle pi r square 22 by 7, 0.14 square. So A2, which is equal to, after simplification we will get 0.0615 meter square. So according to magnetic Faraday's law, minus B, A2 minus A1 by time, E equal to minus B 0.4, A2 0.0615, A1 value already we calculated, which is 0.0484, and time which is 0.2. After subtraction you will get positive, and already in the Faraday's law we have the negative sign according to Lenz's law. So the overall, if you simplify, you will get minus 26.4 millivolt. So minus 26.4, which is nothing but is the third option. Okay. Now coming to the next one, question number 13. Question number 13 is given that a rod PQ connected to capacitor plates which is placed in magnetic field directed downward. This is the PQ rod. If you can see the diagram, PQ is given, this is the rod is moving with velocity V. So, perpendicular to downward, if the rod pulled out from the magnetic field with velocity V, then plate M is positively charged, plate N positive. So, which plate of this capacitor is a positive charge is asking. Further, you can use Fleming's right hand rule. So, according to Fleming's right hand rule, so magnetic field is into the plane and the coil is moving right side. So, current should be upward and the tip it is indicates the high potential. So, the high potential nothing battery is connected P means the point or the capacitor plate N is becomes positive and here it is becomes the negative. So, plate N will be positive charge. Okay. Next question. Question number 14 is given that the straight rod of length L rotating about axis passing through point O as shown. The uniform magnetic field is given to be exists parallel to the axis of rotation, EMF induced between P and Q. Okay. So, we are considering a small length element dx at the distance of x. In this element, the induced EMF dE we are writing which is equal to B L V. V is the velocity, but magnetic field we have 2B. So, EMF dE equal to, according to rotation, V equal to R omega, so that X omega, total EMF they are asking. So, take the integration 2B omega x dx. From where to where? From first end to last end. So, first end at the distance of minus L by 5 and second end it is a distance of 4L by 5. So, EMF E equal to 2B omega taken out, integration of x dx which is x square by 2 limits minus 1 by L by 4 to 5 to 4L by 5. Now, substituting the limits by the 2 cancellation, B omega upper limit 16 L square by 25, lower limit L square by 25. So, 16 minus 1 which is a 15 by 25. Now, cancellation with 5 at 3 times, this is 5 times. So, our answer it is 3 by 5 B omega L square, right. Now, coming to the next one. Question number 14. A small coil of radius R placed at the center of large coil of R, big large coil, inside we are placing a small coil of radius R. Two coplanars, two coils are two coplanar. The mutual inductance between these two coils they are asking. So, mutual inductance we know N phi which is equal to MI. Here the number of turns is not mentioned. So, you can take number of turns is 1, N equal to 1. If current passing through the larger coil is taken as I, then magnetic field flux written as area equal to MI. Due to larger coil, circular coil, current written as mu naught I by which is 2R, area of the smaller coil which is pi r square MI. So, current cancellation, then mutual inductance between these two coils written as mu naught pi r square by 2R. So, mu naught pi r square by 2R which is our second option. Now, coming to the next one, question number 14. Question number 14 says, a induced EMF in secondary coil is 2000 volts, secondary coil, EMF which is secondary coil. When current breaks in the primary coil, the mutual inductance is given 10 Henry current reaches 0 to reach somewhat we have the current, now final current is 0 in 10 power of minus 4 seconds. Max current before it breaks. Okay. So mutual inductance, induced EMF written as minus Cm di by dt, which is E equal to minus Cm change in current I2 minus I1 by time. EMF which is 2000 volts, inductance is 10 Henry, 0 initial current we are calculating, and time is given as 10 power of minus 4. Now simplify, minus of minus plus, minus 4 carried, 1 0 is cancellation, then 200 into 10 power of minus 4, which is equal to 0.2 ampere. So we are getting the second option. Right, now coming to the next one. So it is a 20,000. So 20,000, 1 0 cancellation, 2,000, so 0.2 ampere. Next, question number 17. Here the question is, a wheel has 3 spokes, uniform magnetic field perpendicular to plane, and the axis of rotation of the wheel parallel to magnetic field. When the wheel is rotating, angular velocity of omega, induced EMF between center to rim it is E. One wheel it is there, the wheel it is rotating, so number of spokes is given 3, rotating with angular velocity omega, then center to rim, induced EMF develop ho gaya E. Another wheel having 6 same radius but 6 spokes, number of spokes bad gaya, but same field, uniform angular velocity omega by 4 second case. Then induced EMF they are asking is a rotational EMF, rotational motional EMF. So E equal to of BR square omega, and remember this induced EMF it is independent on number of spokes. So you cannot take the 3 spokes, 6 spokes, 10 spokes. How many number of spokes are given? No issue, the EMF is same. So E is proportional to omega, E2 by E1, omega 2 by omega 1, asking the final EMF, and omega is omega by 4. So final EMF you will get E by 4. So E by 4 nothing but we have the fourth option. Okay. Next, question 18. Question 18 is asking that conducting rod PQ is a PQ rod, 1 meter length, moving with velocity 2 meter per second, magnetic field of 2 Tesla directed into the plane of paper, capacitor of capacity is mentioned 20 microfarad, then which plate having which charge they are asking. Okay. So here we are calculating the motional EMF, BLV, 2 Tesla, 1 meter and 2 meter per second. So 4 volt it is going to be developed motional EMF. Charge we are calculating, charge Q equal to CV we know, C which is 20 micro, potential is 4, which is 80 microcoulomb the charge it will come. But which is positive and which is negative? Again going with the right hand Fleming's rule. So the rod it is magnetic field into the plane, the rod is moving right side direction, the current should be upwards, so current should be upwards. If you complete the loop, the conventional current is flowing from A to B, conventional current, but electrons are flowing from A to B. Conventional current is from B to A, but electron is flowing from A to B. A is a loss of electrons, B gain of electrons. Gain of electron nothing but we are getting the negative sign. Loss of electrons nothing but we are getting the positive sign. So plate A having plus 80, plate B having minus 80 microcoulomb. Okay. So our answer is second. Next, question number 19 is given that some magnetic flux is changed from coil resistance mentioned. As a result, induced current developed in it. So, given the graph current to time and asking the magnetic flux in the coil, flux they are asking. Okay. So, first we need to find flux charge is equal to magnetic flux by resistance. First we need to find the charge. How to calculate? Take the area of this graph, it represents the induced charge. So, charge Q equal to is a triangular half into base into height, half base 0.1, height it is 4. So, charge you will get 0.2, it is in coulombs only. Then charge 0.2, asking the change in flux, resistance is 10, then change in flux you will get it 2 Weber. 2 Weber, so we have the second option. Okay. Now, coming to the next one, question number 20. Question number 20 is given 10 metallic spokes, each length is 0.5 meter long, rotated with omega 120 revolution per minute, converting into radian per second, 2 pi by 60. So, cancellation, which is 4 pi radian per second. Normal to earth magnetic field, and magnetic field is given 0.4 Gauss. Gauss converting into the Tesla minus 4. Induced EMF between axle and the rim. We need to find the induced EMF. So, rotating rod of BL square omega, number of metallic spokes is mentioned as 10, but already we discussed earlier, the number of spokes doesn't influence the EMF, so no need to multiply with number of spokes. Then EMF is developed in each spoke is same as 10 spokes because all are in parallel combination. So, higher potential, lower potential, higher potential, lower potential. Now, all the cells are in a parallel combination. So, effective EMF is same as any one of the EMF in the cells. So, that no need to multiply. Now, simplifying of magnetic field is 0.4, 10 power of minus 4. Length of each spoke half meter cos square, and magnet omega, which is 4 pi, pi is 3.14. Just multiply, simplify, you will get 6.29, 10 power of minus 5 volt. So, our answer it is third. Next, coming to next one, question 21. So, conducting circular loop xy plane, presence of magnetic field given vector form. The radius of loop r is mentioned. EMF is induced in the time of 2 seconds is n pi volt. Asking the N value. EMF, so EMF we written as minus d phi by dt. Taken the magnitude, magnetic field induction or area dot product by time. Magnetic field, which is 3t cube j cap, 3d square k cap. Let us calculate the flux B bar dot of A bar separately, and A is a area which is pi r square, right. So, it is in the xy plane, the loop in xy plane. So, area vector is radially outwards. So, along z-axis nothing but you can take the k cap. Now, take the dot product k dot k, which is equals to 1. So, 3t square into pi r square, and asking the EMF, r value we are substituting, 3t square, pi radius is 1. So, the flux which is equal to 3 pi t square. Now, the EMF d phi by dt, d by dt of 3 pi t square, which is 6 pi t EMF, Now at the time of 2 seconds, so just substitute 2 seconds, you will get 12 pi volt. So if you are comparing with the given n pi, then the value of n is equals to 12. So n is equal to 12. Okay. Next, coming to the next one, 22nd one, a square frame side 10 centimeter, 0.21 meter, carrying the current of 1 ampere in the plane of paper, starting from close to wire, the frame is moving towards the right side with velocity of 10 meter per second. Okay. So induced EMF at the time left arm frame 10 centimeter, from the wire it is given mu microvolt, x microvolt, x we need to find. So this is the side which is close to the wire. So magnetic field written as B1, and this is the side is away. Magnetic field is taken as B2. Current is upwards. So due to the current, magnetic field is developed is into the plane. Now apply the right hand Fleming's rule. Magnetic field into the plane, right side. So you can take the current is upwards. So here you can take the high potential and low potential, and continuation you will get here is a low potential and high potential. Sorry, here it is the same direction. So here also you will get same high potential and low potential. Same magnetic field into the plane, current velocity right side, and current should be upwards. So high potential, low potential. Now the battery you can replace like this in this frame. But magnetic field is different beta, B1 or B2. So effective EMF B1 minus B2 L into V. Now simplify. B1 mu naught I by 2 pi x. X is given 10 centimeter. 10 centimeter. 10 centimeter converting into the meter, minus B2 mu naught I by 2 pi, second side 10 plus 10, totally 20 centimeter, converting again meter. Length it is given already, it is a 0.1 meter. Velocity is 10. Mu naught by 4 pi, 2 into 10 power minus 7. Current is passing 1 ampere. So 10 power minus 2. And same 2 into 10 power minus 7. 2 into 10 power minus 2. 20 into. And here it is a value of 1. Just go through the simplification, right? You will get after simplification, you will get 1 into 10 power minus 6 volt. So which is nothing but EMF micro volt, then the value of x, if you are comparing, the value of x you will get which is 1. 1. Not volt, it is only 1. Right? Next. Next question. 23. Two rings of radii r and 2r moving in opposite directions with velocity 2v and v respectively on conducting surface is S. This is a uniform magnetic field magnitude B perpendicular to the plane of ring is given already into the plane. So potential difference between highest points of the two rings is given. P value we need to find. Okay. Highest point is a conducting surface. Highest point. Same right hand rule we are applying. Magnetic field into the plane. Smaller ring moving left side direction. So current is should be downward. Downward is a high potential tip. So if we combine topmost point to ground, downward, high potential down. So it is total length r plus r, which is 2r. So EMF induced E1. Second ring, magnetic field into the plane, moving right side and should be current upward. then high potential also it is going to be upward. Then you can replace with battery two topmost points. Length 2R plus 2R, which is 4R. EMF it is E2. The value of EMF, which is BLV, length is 2R, moving with velocity 2V. So EMF you will get 4BRV E2. So which is nothing but again BLV from we are calculating magnetic field B, length is 4R, velocity is V. So E2 equal to 4 BVR. But these two cells are connecting with unlike polarities in the series combination. In the series combination, effective EMF, which is E1 plus E2 when unlike polarities are added. We are doing the same thing, E1 plus E2, which is 4 BVR plus 4 BRV, so which is 8 BRV is the total EMF between two highest points. If you are comparing the given equation, which is root P BRV, root P equal to 8. So squaring on both sides, 8 square, which is nothing but 64. So our answer is equal to 64. Okay? Thank you.